we present TCFG, Truncated Classifier-Free Guidance for Efficient and Scalable Text-to-Image Acceleration. Text-to-image generation has made remarkable progress, yet its computational demands remain a significant barrier to widespread application. A key component in this process is Classifier-Free Guidance, or CFG, which enhances the alignment between generated images and the input text. However, our research identifies a critical inefficiency within the current CFG process: substantial computational redundancy. We observed that as the denoising process progresses, the conditional and unconditional noise estimates become nearly identical. In other words, the text input becomes unnecessary in the later stages of denoising. This presents a clear opportunity. If we can truncate the text-related computation at the right moment, we can achieve significant computational savings without sacrificing image quality. This leads to our core research question: when can we safely stop the text-related computation? Our core assumption is that the text input can be ignored once the semantic content it describes has been successfully established within the image. To demonstrate this, we initially generate an image using the original text photo of a blue bird, the first row. Subsequently, we shift the color, blue to yellow, at different time steps to assess the preference of the denoising unit. The results indicate that, when confronted with overtly contradictory conditions, a blue bird in the visual input and a yellow bird in the text prompt, the denoising unit prioritizes the visual input if it clearly depicts a blue bird second, and third rows, and disregards the conflicting text prompt. An intuitive explanation for this behavior is that the visual input, which depicts the specific appearance of the bird, provides a more accurate condition compared to the text prompt, leading the denoising unit to lean towards it. Only when the blue bird is highly ambiguous does the prompt exert an influence on the final generated image, the last row. To operationalize this, we need a robust method to determine the moment of content establishment. Our solution is to leverage the bottleneck features of the unit. These features contain the richest semantic information. By measuring the distance between the bottleneck features of the conditional and unconditional outputs, we can quantitatively assess how established the text-guided content is. A small distance indicates redundancy, signaling it is safe to truncate. Furthermore, we provide a novel theoretical interpretation of CFG. We demonstrate that the CFG update formula, viewed as an implicit stochastic gradient descent optimizer on the sample space. This perspective allows us to borrow well-established concepts from optimization theory. Specifically, we integrate warm-up and decay strategy directly into the denoising steps. This warm-up fosters faster and more stable convergence of the semantic content, making content establishment happen faster and allowing for even earlier truncation. In our experiments, we use the DDIM50 sampler to evaluate TCFG against strong baselines, including deepcake and token merge. Quantitatively, our method achieves a substantial speed while maintaining competitive image quality, as measured by standard metrics like fit and clip score. Qualitatively, the generated images are visually indistinguishable from those produced by full CFG process, confirming that truncation does not harm the final output. In conclusion, TCFG offers a simple, effective, and theoretically grounded approach to accelerating text-to-image generation. By dynamically identifying and truncating redundant text computations, we achieve scalable efficiency gains. We believe this work is a meaningful step towards making power accessible and practical. Thank you for your attention. Free to contact us if you have any questions.